Okay, Pavi, thank you very much for that fun introduction, because we are going to have some fun today. We're going to do a little bit of math even, and share some of our lessons that we've learned at Cisco as we've introduced new services that are powered by AI and machine learning. And we think they apply to a lot of stages, really, of companies. So we're going to have a little bit of fun with it today. Get my clicker here. First, I'm going to explain a little bit about our unusual name of our conversation. And we like to think about Iron Man and Iron Women, right? With services, we think about smart people powered by technology. So if you're not familiar with the movie Iron Man, I know John is a huge fan. He just took his whole team to see the Avengers movie.
That's right. It was awesome. If you haven't seen it yet, definitely go see it.
Right. So if you're not familiar with it, Tony Stark is an amazing engineer, and he creates a powered exoskeleton. So both those things are really cool individually, but when they come together, they are Iron Man. It creates Iron Man. And since we have amazing men and women in Cisco services, we have a bunch of Tony and Tanya Starks. So people who are powered by technology. So first, let me just have both of you, John and Antonio, introduce yourselves.
Sure. First, I think we have to address that this isn't Rajat, right? So I want everyone to give her a hand, because she had like a half-hour notice, and so she's pinch hitting, so please give her a hand.
Thank you.
Thank you.
I'm understudy here.
Awesome. Fearless and brave, so thank you for that, Maya. Team, my name is John Bunney. I lead services at Cisco for the TAC, the global TAC, specifically for data center and core technologies. We do about 2.2 million service requests per year.
Awesome. Antonio.
Hi, everybody. Pleasure to be here with all of you today. My name is Antonio Nucci. I'm the Chief Technology Officer of Advanced Technologies and AI in support of what is now known as a Customer Success Organization. And John is my partner of crime. You will see very soon.
Great. John, let's start with you. Cisco TAC. Tell us about some of the biggest challenges your customers are facing.
Yeah, so, it doesn't take a lot of brain knowledge to know that quality in my job, we see it every day, right? So if anyone has an issue, whether it's, I don't know how to configure this device or piece of software, or if an issue crashed, they're going to be calling my team. And so quality is a very large issue. And I think we have a slide, if you forward it, because it's a little bit of fun here. There we go. Is that the right one?
Yep.
Oh, okay, good. So, we did some math, and we said, how big of a quality issue is it? So I got a quiz for you guys. We'll take the top 10% of features of iOS XE. It's about 170 issues, right? 170 different devices. So if you think of that as a dev test or QA engineer, how many unique combinations, now here's your hint, it's combinatorial math, because I know we got a lot of engineers and smart people out there. How many different test combinations would you have to do just for 170 features, every which way? Okay, well, let's give them a hint. Let's give them a hint. There you go. How does that help you? All right, well, probably for most of us not. Let's flash forward to the answer. That's the answer. It's 1.5 times 10 to the 51st power. Have to memorize that, right? Because you can't see it. To put that in context, 1.5 billion different test scenarios, okay? Now, is anyone in the audience from test, QA test, or any aspect of quality? Raise your hand. I see one hand. Give that person a hug, because they have an impossible job. Quality, a perfect release will never happen at the complexity that we're at. This is not just a Cisco issue, it's a whole market issue. Now, remember, that's one device. What happens when it's a whole ecosystem of hardware, software, firmware, third-party vendors? You can imagine that I feel pretty good about my job security.
Right, yes, because you have big problems on your hands to fix. So what are you doing to help customers work through it?
That's right. So for the past 30 years, Cisco's been known for some of the best support in the industry, for networking, et cetera. We take a lot of pride in that. But over the years, times have really changed. Is it appropriate for us to wait for things to break? Think about that. Should we be fire women and men, where we rush to the accident and clean up the mess? Or is it really about getting out there with the knowledge we already have as a vendor to inoculate that user base? Think of an antivirus. Does an antivirus wait for their people to be compromised? Or do they take action? The first time they see it, they're coding the inoculation and then sending that out to take risk out of their customer's environment. So we've made a commitment, Maya, to basically do all CFDs that we can, customer-facing defects, PCERTs, which are our security alerts, and field notices that we alert, because we think that's the minimum viable, that as a vendor, if you're not taking care of your customers and digitizing that for auto detection, and hopefully someday auto remediation, then you're not doing your fiduciary duty as a vendor. So that's how we look at it.
Right. So tell me a little bit more about kind of the experience.
Are you technical, Maya?
No.
Not at all? Okay, can you put on a TAC engineer's hat for me right now?
I'd love to.
All right, now you are a TAC engineer. It's your first day on the job, okay? And everyone, you can put yourself in the same situation. You're grabbing a cup of coffee, your mentor has sat beside you in that nasty severity 1. The highest severity comes in, and you notice it's a trading floor down overseas, okay? And your mentor says, ooh, this is a tough first case to take, but let's do it anyway. And as you're ready to prepare to take that case and talk to the customer, you realize that your senior vice president is now calling you, explaining to you in great detail how important this issue is. So are you feeling a little nervous?
I'm good under pressure.
Okay, good. I'm glad you're good under pressure. So to help visualize this, I asked for a couple participants to come in. Param and Shri, can you help me out? And we're going to upload the logs now.
Okay.
Does that sound like a good idea?
I'm ready to dig through them so I can fix this problem.
All right, good. All right, so here come the logs, and this must be a competitor's router and switch because it's very slow,
Right. But we service everything.
All right, so the logs are uploaded.
Okay.
I guarantee you the answer is in there.
Where's the file that I need?
Well, it's in there somewhere. I mean, this is the log file, right? It's a representation, maybe about a gigabyte worth of data. Now, you got a little lucky today because ACI is 18 gigs. So imagine 18 of those, right, in a production system.
So I just open all of those up and read through them?
Looking through it, yeah. How do you feel?
Not so good.
Chuck's getting a call in about 30 minutes. You better pick up the pace, right? So we won't pick on her too bad, but not a good feeling, right?
Not a good feeling.
And the pressure's on, et cetera. So imagine now you get this in your inbox.
Okay.
And what it would do for people who can't see is highlight everything that we know that might be wrong with that issue. This is known data. This is not unknown issues. These are about customer-facing defects. We know about security alerts, et cetera. And what you can see here...
I have the error message right here. It tells me exactly what I need to do.
Exactly. So now you're on the phone with the customer. How do you feel now that you're equipped with the answer?
Perfect.
You didn't even need to know, right? Pretty good experience?
Yes.
That's what we're doing. This is in production today. It's around digitizing our known knowledge and putting it into an auto detection system. Now, in that Iron Man situation, we really see ourselves as Tony Stark, the human, right? We're not the machine per se. We are digitizing, we are taking advantage of automation, but we need to go further and faster for our customers.
Those are great stories. So what is next for customer experience in your world, right? And most importantly for the rest of the group here, what can people learn from what you've done?
So I think the first and foremost, we have a lot of fun, but really if you're, whether you're a big company or a small company just starting out, taking the time to really make sure your data is in order. Because with machine learning AI, you know that dirty data is garbage in, garbage out. So take care of your data, really have a data strategy. Take time and really understand the customer experience, that sometimes a vendor has a ton of knowledge over their gear. How do you encapsulate that and make sure you're sending it out to alert customers, protect customers? And then I think I'm really excited what Antonio and his team are going to bring Cisco, because that's the next generation. That's when the human work kind of clears the way. We're cleaning the data, we're using that human intelligence and teeing it up for the machines to take over.
Right, so we move from that continuum, right, from reactive to proactive, preemptive, et cetera, ultimately to autonomous. Right. And that's a great segue, right, to Antonio. So tell us a little bit about this transition between...
Yes, so as John was saying, we've made quite of a major breakthrough to automate all the process, digitize all the IC, such that we can really cut down drastically the time to completion, time to resolution of any case opening. So where my team comes in is, to even avoid the case to be opening. What does it mean? Avoid is what about if network would never fail? What about if our customers would have guaranteed a 100% network uptime? Well, that is quite of a stretch and objective because what we are really saying is in this journey of evolution of analytics is how you move now the needle forward from proactive into predictive intelligence systems. And sticking with the same example of the network outages here, the network uptime, the problem is very complicated because network failures are really rare. So that implies for data scientists, unfortunately, you don't have much of data to learn from. So that is where the machines come in. They have to squeeze all the single drop of juice out of the, well, we have a slide there, out of the 0.1% of data that we do have that is trustworthy. And the second thing is that when they happen, they are devastating. So customers are really impacted from a revenue perspective, are impacted from a brand, a marketing perspective. There are most of the times there are also legal ramifications if they lose any data. And the labor cost incurred in fixing the problem is outrageous because, these are like the top people that your boss asks to stop what you are doing, fix the problem because Chuck is waiting an answer 30 minutes, correct? So there was a study that was done just very fresh in 2017 and say that a typical Fortune 500 company, every time that it goes into a failure mode, is labor cost, meaning fixing the problem, accrues to $300,000 to $500,000 an hour. And the downtime, well, of course, depends of if you are small, medium, and large, or enterprise or ISP and content providers can go from 87 hours of downtime a year to over 500 hours of downtime a year. You do the math. The math is big. The problem really.
Well, I did advance the slide, and I saw, and I have the math problem up here. I have actually noticed a couple people trying to calculate it. So maybe you can walk us through.
Well, following this exact same example of John, sticking with the same device, the same hardware configuration, the same software version, now we're talking about how many possible error codes, unique error codes does this device generate, because an error code is really what we are going after. What are these predictive sequence of error codes that lead to future failures, that needs to be fixed before actually the failure happens. So the problem is really clearly mapped, let's say with 100, just to make the math easy, for how much it could be easy, let's say that you have 100 distinct error codes, how many unique sequencing we needed to mine to compute the probability of a future correlation in time. And I'll give you an hint, this is you can map it as an association rule mining problem, market basket problem.
Anyone?
Below there is the hint, and the number, I think, is just a little bit shorter than John. I'm missing 3 zeros. But this problem has been oversimplified. We're talking about one device. We're talking about only 100 error codes. The network is much bigger. We're talking about 60, 50, 100,000 of devices that are interconnected and moving the problem to their neighbors as a hot potato problem. And so when you really add up all the complexity of covering an entire network, you should add 4 to 6 more zeros to this. So I'm going to beat you.
Right. So tell us, what is Cisco's secret sauce to help customers with this?
Yes, in the world of predictive intelligence systems, and this is also one of the important technology takeaway. It is just unrealistic to assume that one library or algorithm or tool or capability is going to get you there, correct? If I had to pick like the problem, model this with the greatest of TensorFlow, STM, or logistic regression, say, okay, give me predicting the rule, we're not going to get there. How you move the needle from a search space that is 10 power 49 or 53, 54 network-wise into the 3 error codes in a proper sequence, leading to a specific failure that can happen days after. So it's a concatenation of tools capabilities, and you are going to be borrowing capabilities from artificial intelligence, machine learning, deep learning, and it's how you organize all these capabilities into a proper analytical workflow that really makes a difference. So just at high level, how we approached the problem was first to make the problem manageable from a machine perspective. What does it mean? This data comes very unfriendly. It's very unstructured. And they cannot be understood by any kind of machine learning or deep learning algorithm. So the first one thing is how do you transform unstructured data to structured data without losing the important information like the locality of the issue, the specificity of the issue, and so on and so forth. Then there is the problem of how do you reduce the space, or the space of these possible error codes that are relevant to the target event. So here we have a major step in the methodology that goes after modeling the behavior of a device and trying to infer the internal state of a device. Is the device healthy and happy, or is the device entering into a failure, so transition into a failure, or is actually recovering from a failure, or is it back to be stealthy and happy? As you are able to slice the time span of every single device and you have a model that is accurate, that implies that you can really cut off a specific time slice. That is where really you're going to go after the important error codes are likely to be correlated to the pattern. And then there are a bunch of other techniques that goes from temporal correlation, spatial correlation. Finally, is the generation of the probabilistic rule that really is the important aspect of the problem. A rule that has to be accurate with high true positive, almost a zero false negative. We cannot tolerate false negatives in this scenario, and that can really lead into the appearance of the future problem with great confidence and trust.
So, John, tell us a little bit about how this work ties into TAC. How do you see this?
Absolutely. So, Maya, we talked about digitizing, automating the detection of known issues. But as we see, there's so much opportunity for different things to pop up, especially when you talk about interdependencies between different components, et cetera. So we have to, it outpaces the human. There's a reason Tony Stark made that suit, right, to fight crime, right? It was because he was outgunned. Well, we have to realize that where complexity is headed, our support engineers are outgunned. So without technologies and machines bridging that gap to get us to where we need so that we can delight our customers, predict, prevent, and hopefully someday become fully autonomous in support, then we've lost the war before we've begun. So this is incredibly important technology teaming up with those humans who's creating and cleaning that data.
Right, great. So we will invite questions. So if you do have some questions, please feel free to approach the mic. But before we do take questions, I want to ask both of you, right? We have a room full of entrepreneurs, aspiring entrepreneurs. Tell us if you can share, one key takeaway, what would it be?
I think if you're going to the market, and noting this is a room full of entrepreneurs, when you're going to market, many of us think about our product first, which is good and correct. But if you are ignoring that post-sales experience, that what do customers do once they have it and something goes wrong, you will fail. If you aren't considering going beyond reactive into proactive, predictive, preemptive, autonomous, then you will fail in the long haul because you won't be able to scale. Your customers will have a terrible experience, and OpEx is everything, right? And so I believe the stat was for most of networking gear, I think it's 90 cents on the dollar of IT spend is on OpEx, only 10 cents on infrastructure. So pretty interesting, right? So that gives you an idea of how much our customers invest in that, and how can we ease that burden, not only of pain and suffering and downtime, but also OpEx reduction over time.
Right, great, of course. Antonio, what about you?
Yeah, so I'm going back, to my point about the importance of the data, and that, I mean, the results that we show before with this predictive, the ability now that Cisco has to predict failures days in advance, such that we avoid the case opening for John, is a combination of two things that are very important. First, John and his team were able to clean the data such that 0.1% of the data was gold mine for us to derive all these, to train all these models. And the second thing that I'm gonna go like beyond my Cisco experience, but more like from the first day where I finished my PhD into all my industrial career, always approach the problem without, by taking really many different kind of vantage points. Don't rush the 1, 2, 3 algorithms that are the first one that pop up in your mind, and ask the basic question of what can I learn from the data. So there is no one single algorithm, as I said before, that is going to get you to these kind of results. So good data, great, machines are happy, humans come in to understand what can I learn from the data. At that point, you approach the problem, by segmenting, and building your entire pipeline.
All right, so we can take some questions.
Excellent introduction to the technology you guys are building. Could you just shed some light on what was the level of effort that you had to invest to get where you are today? How long it took, man hours, kind of people, just some high level, right? Whatever you can share. Yeah.
Sure, I'll start with that. That's a great question. To get started, it's a bit daunting. And one of the reasons I said, think of this if you're an entrepreneur, start at the beginning, it's much easier. What we did is we actually took a snapshot of known issues, again on the human side, of 18 months of data. Because we know that constantly technology is moving and things will drop off of end of life, end of sale, end of support. And so what we felt was an appropriate measure to do our duty to protect our customers was to go 18 months back to that data, to clean it, to digitize it, so automate detection. We've been on this journey creating some internal systems that we've created ourselves and some external for about 18 months now. And we are about 65–70% of the way through that digitization effort. Now that doesn't include all of Antonio's work, but that was give you some idea. As far as man hours, we have about 22,000 different issues we're detecting today. Each one of those, depending on the method, takes between 45 minutes and an hour to create, on average, I would say. So that'll give you some idea. But remember, we're a pretty large company, but it would have been nice had we started at the beginning. We wouldn't have to do these huge sprints. So, Antonio?
And this is based on what we know, but Cisco ships product every single day. So, I mean, what we don't know is still big. And that is why also the machines have to come to picture. For example, how much information is embedded in TAC calls with customers. Is another big set of data that we're trying to automate the process of creating intellectual capital, digitize intellectual, and augment John's team with knowledge. I mean, it's a journey, and we are on a good trajectory, but definitely this is just the beginning of a very interesting journey.
Great, next question.
And Antonio, this is fantastic. So with the AI implementation, how much reduction in the TAC force you have done in Cisco?
Okay, great. I'll take it first, and then a lot of what Antonio's work, we're just rolling in now, but I'll give you the stats that we have. We just did a 20,000 case study and said, okay, what's the time differential between a detection and a non-detection for a bug, as an example? We saw a 45% reduction. In time, huge amounts. And I actually think it could be much higher, but sometimes when we have bugs, right, a customer will say, leave it open until the fix is there. And obviously we want to make sure it fixes the issue. So there is actually padding in there where sometimes we detect it. Like I said, this detection piece, if we know what it is, it will detect it like that within minutes. So it's actually taking whatever it would have been before. Sometimes, in really sticky situations, we've seen 2 months getting shaved off, where engineers will go round and round, they'll talk to engineering. It's extremely exclusive or elusive, I should say, bug. It could take us 2 months in the extreme, and down to automated once we get the log. On average, like I said, in the 20,000 case study we did, it was 45% though, which is not insignificant.
Yeah, in terms of prediction of failures, this is like quite of a new capability that is one of the very first in the predictive space. And on average, out of all the tests that we've done with several of our biggest customers over the last 18 months, I can say that the time to failure, what we call the time that elapses between when our predictive pattern says you're going to have a problem, and the time actually that the customer is going to have a problem is going to become John's problem at that point, is an average of 11 hours. So remember that a good chunk, I would say, I don't have the percentage, but a good I would say 80. John has some more precise number, but a good 80% of all the problems can actually be fixed in less than 1 hour. So this is what I'm saying. With a time to failure that is plenty. To go and deploy an actual fix. The network is never going to get into that ugly phase where it's going to translate into business issues. So.
Great, and if anybody wants to continue the conversation, I know we're pressed for time now. We are hosting a networking event in room 203 very shortly, so if anyone wants to approach us with other questions, we'll be there along with some of our colleagues. Our team is growing, and we'd love to talk more about it.
Thank you, team.